we are on a collision course in mutual descent towards our neighboring large galaxy, Andromeda.
We are currently headed on a path towards our neighboring vast galaxy, Andromeda, in what seems like a mutual descent. Did you realize that Andromeda has been hailed as a cosmic revelation, reminding us of our insignificance in the grand tapestry of existence? It shattered the illusion of our centrality, showing us that we're just a tiny part of a much larger cosmic picture. This understanding might make us feel minuscule amidst the vastness of the universe. Our understanding of Andromeda has expanded significantly over the past century, largely through observations from Earth. However, with cutting-edge tools like the James Webb Space Telescope, our perception of the universe has undergone a profound transformation. The James Webb Telescope has unveiled aspects of Andromeda that challenge our previous conceptions, revolutionizing our understanding of the universe in unimaginable ways. Join us as we delve into the enigmatic stories concealed within the Andromeda Galaxy, uncovering secrets that have evaded us for a century. Just over 100 years ago, the Milky Way appeared to most as a faint, ethereal band of light stretching across the night sky. Limited by the technology of their time, astronomers couldn't discern individual stars within the Milky Way. Various interpretations abounded, often associating it with the center of the universe, where the realms of the celestial and the earthly supposedly converged. In the early 1600s, the pioneering Italian scientist Galileo Galilei, armed with his groundbreaking telescope, revolutionized our perception of the Milky Way. His discoveries starkly contradicted Aristotle's notions about the cosmos, revealing the Milky Way not as a mere band of light, but as a vast expanse teeming with distinct stars, planets, and celestial bodies. Behold the wonder of the Milky Way galaxy, a marvel in our cosmic neighborhood. Andromeda, our closest galactic neighbor, beckons us to explore its mysteries. The observable universe boasts around 100 billion galaxies, a staggering spectacle. Though daunting, we muster the courage to count the stars in this awe-inspiring display of creation. Through diligent observation, we uncovered a truth that reshaped humanity's understanding of the cosmos. The Milky Way does not occupy the universe's center as previously believed. Instead, it comprises myriad stars strewn across the celestial canvas. In 1750, the English scientist Thomas Wright introduced a significant concept in his work, an original theory or new hypothesis of the universe. Wright proposed that the Milky Way's formation as a flat line of stars suggested it was more than just a product of random chance. He boldly suggested that within this expansive structure lay a component housing our solar system. While Wright's theory marked a significant stride in understanding the organization of the Milky Way, it was constrained by the technological limitations of its time. With observational tools restricted in capability, the prevailing belief was that the Milky Way encompassed the entirety of space, reflecting the constraints of the era's technology. However, by the early 1800s, our comprehension of the universe had expanded tenfold, with the subsequent century yielding numerous breakthroughs. In the 1920s, a pivotal revelation by the renowned American astronomer Edwin Hubble sparked a profound shift. Using the formidable 100-inch Hooker telescope at the Mount Wilson Observatory, Hubble scrutinized distant nebulas concealed beyond the Milky Way. After years of meticulous examination, Hubble made a monumental discovery that reshaped the course of astronomy. These celestial entities were not mere constituents of the Milky Way, but distinct galaxies, each teeming with billions of stars. Hubble's revolutionary findings shattered the once confining boundaries of cosmic perception, unveiling a cosmos replete with galactic marvels beyond our own Milky Way. Andromeda, also known as M31, stands as one of the scarcely visible neighboring galaxies. This celestial entity has been the subject of extensive study spanning centuries. One of the earliest documented sightings of Andromeda dates back to the 10th century, credited to the Persian astronomer Abd al-Rahman al-Sufi. In Al-Sufi's celestial charts, Andromeda appeared as a diminutive cloud, earning it the moniker the Little Cloud. Al-Sufi's ability to observe this distant cosmic object without the aid of telescopic lenses underscores the significance of his observations, achieved through keen eyesight and astute observations. Andromeda's prominence as one of the few galaxies visible from Earth's surface, unaided, distinguishes it. Spotting it amidst the vast expanse of the sky demands keen vision and a firm grasp of navigation. The realization that the heavens harbor more than just stars is profound. Although initial detailed observations of Andromeda emerged in 1612, courtesy of Simon Marius's telescopic views, subsequent astronomers built upon his meticulous groundwork to glean further insights into this colossal cosmic structure. In 1764, the renowned French scientist Charles Messier included Andromeda in his stellar catalogue, designating it as M31. Despite wrongly attributing its discovery to Simon Marius due to his unawareness of Al-Sufi's prior work, Messier played a pivotal role in elevating Andromeda's prominence in astronomical discourse. Subsequently, scientists worldwide embarked on nearly a century of relentless pursuit to unravel the enigmatic tapestry of this celestial marvel, with each new revelation building upon its predecessors. A significant stride in comprehending the essence of the Andromeda Galaxy was made by the English scientist William Huggins in 1864. Delving deeper into Andromeda's spectrum, Huggins discerned a distinct divergence from the typical signatures of a gaseous nebula. This pivotal discovery facilitated a deeper understanding of Andromeda's essence. Andromeda, with its staggering enormity, is believed to possess a mass between 1 and 2 trillion times that of the Sun. This colossal celestial entity resides in close proximity to our own location within the vast expanse of space. According to current research, Andromeda is estimated to be approximately 10 billion years old, marking it as an ancient cosmic artifact with a rich history of formation and evolution, characterized by a cosmic ballet spanning eons. Among the fascinating theories regarding Andromeda's genesis is the notion that it originated from the intricate dance of several smaller galaxies in space. This hypothesis posits that over billions of years, these diminutive galaxies coalesced under the influence of gravity, giving rise to the resplendent Andromeda Galaxy we behold today. Such cosmic mergers, integral to the grand tapestry of the universe, sculpt the growth and morphology of galaxies. However, these cosmic pas de deux unfold at such a gradual pace that their observable manifestations only emerge during pivotal junctures in their evolution. Previously, scientists conjectured that Andromeda boasted significantly greater mass than our Milky Way galaxy. Given our vantage point within our own galaxy, accurately gauging cosmic proportions becomes challenging, rendering such misconceptions understandable. The apparent distortion in Andromeda's size when viewed from Earth might have perpetuated the notion of its unparalleled magnitude. Nevertheless, recent scholarly endeavors have prompted a re-evaluation of these long-standing convictions. Scientists have adjusted their estimates of Andromeda's mass following new data, while concurrently revising their estimations of our Milky Way's mass. Despite these revisions, astronomers remain confident in their understanding of Andromeda's true dimensions. It spans a considerably larger area than our Milky Way, boasting a diameter of approximately 220,000 light-years, significantly surpassing our galaxy's diameter, which ranges from about 100,000 to 175,000 light-years. Given its immense scale, Andromeda indisputably holds the title of the universe's largest star, claiming a vast swath of space as its domain. This revised perspective underscores the complexity and challenges inherent in accurately measuring galaxy mass. Galaxies, being vast systems, have their mass intricately intertwined with the dynamics of stars, gas, dust, and dark matter within them. Precise determination of these figures demands sophisticated observational tools and meticulous analysis, capabilities that were beyond the reach of astronomers in the 1700s or even the 1800s. The revelation of this truth underscores the critical role of modern instruments in advancing our understanding of the universe. The active galactic nucleus, AGN, of the Andromeda Galaxy stands out as one of the most captivating features of the galaxy. It constitutes a dynamic and highly energetic region at its core. The AGN resembles a whirlwind of intense emissions spanning various wavelengths, from the gentle whispers of radio waves to the electrifying chorus of X-rays. At the heart of the AGN lies a supermassive black hole, a cosmic behemoth whose incomprehensibly high density poses a challenge to understanding. These gravitational behemoths harbour an unfathomable amount of mass within an extraordinarily compact space, exerting a profound and enduring influence on the surrounding cosmos. Astronomers utilize advanced telescopes like the Hubble Space Telescope to peer deep into active galactic nuclei, AGN, and witness a stunning phenomenon, a bifurcated cluster of light. This dual manifestation indicates that the AGN possesses two distinct focal points. The brighter of these serves as a beacon, directing attention toward the supermassive black hole positioned slightly off-center from the galaxy's core. Scientists have approximated the mass of this cosmic behemoth to range between 1.1 and 2.3 x10 circumflex 8 solar masses, equivalent to 110 to 230 million times the mass of our Sun. Supermassive black holes reside at the hearts of many galaxies, including our Milky Way. Their immense gravitational influence significantly impacts the evolution and motion of galaxies when gas or stars venture too close, succumbing to their powerful gravitational pull. This gravitational attraction causes matter to spiral inward, forming an accretion disk encircling the black hole. The swirling vortex of material undergoes a tumultuous transformation, emitting waves of luminous energy across the electromagnetic spectrum. The extraordinary brightness of AGN stems from this incessant torrent of light, offering insights into the intricate interplay of cosmic phenomena on vast scales. Researchers focusing on the active galactic center of the Andromeda Galaxy discern a luminous region proximate to the supermassive black hole at its core. This remarkable occurrence arises from the complex gravitational interplay between the black hole and the stars ensnared within its gravitational sphere. Situated at the core of the Andromeda Galaxy, the supermassive black hole exerts an extraordinary gravitational force, drawing nearby stars into its cosmic embrace. As these stars traverse elliptical paths akin to planets orbiting the Sun in our solar system, they reach a critical juncture known as the perihelion. At this juncture, stars hurtle at their maximum velocities due to the gravitational pull's intensity. This gravitational ballet culminates in the formation of densely clustered stars near the black hole. During this process, stars emit energy spanning the electromagnetic spectrum, encompassing visible light and various types of electromagnetic waves. The heightened brightness observed at the focal point within the core of Andromeda's active galactic nucleus, AGN, results from the increased density of stars and the radiation they emit. This distinctive characteristic offers valuable insights into the dynamics of gravitational forces and the intricate interplay between the supermassive black hole and its surrounding stellar companions. Another intriguing aspect of the Andromeda Galaxy is its abundance of globular clusters. These densely packed assemblages of stars orbit the galactic center akin to moons orbiting a planet, adding an additional layer of intrigue to the cosmic tapestry. Andromeda is believed to harbor approximately 460 of these ancient, dense clusters. Each cluster comprises hundreds of thousands to millions of stars that coalesced simultaneously. The substantial presence of globular clusters in Andromeda serves as a celestial time capsule, harboring crucial clues about the galaxy's evolutionary history and its interactions with smaller galaxies over billions of years. The prolific occurrence of these clusters suggests that Andromeda has actively engaged in galactic cannibalism, a process wherein it absorbs stars from smaller galaxies that venture into its gravitational domain. As smaller galaxies succumb to Andromeda's gravitational pull, their star constituents are assimilated, seamlessly integrating into Andromeda's stellar tapestry, enriching its diversity and augmenting its stellar population. Such assimilation of globular clusters and stars from smaller galaxies is characteristic of spiral galaxies like Andromeda. Spiral galaxies, with their disk-like structures and prominent spiral arms, are conducive to interactions and mergers with smaller galactic companions. In addition to its array of captivating features, recent observations and analyses have led astronomers to speculate that Andromeda may be undergoing a significant transformation. Transitioning from a typical spiral galaxy to a less common ring galaxy, Andromeda's metamorphosis captures the fascination of astrophysicists. Ring galaxies, characterized by their ring-like structures, which can be either spherical or elliptical, are adorned with young, blue-hued stars encircling the bright rings, while the central regions exhibit minimal luminous matter. These distinctive attributes render ring galaxies as unique stellar entities amidst the vastness of space. In a typical galaxy, there are three primary types of optical rings: nuclear rings, inner rings, and outer rings. Nuclear rings are situated close to the core of the galaxy, while inner and outer rings are positioned farther away. Moreover, ring galaxies can be categorized into two main groups: O-type and P-type. O-type ring galaxies feature nuclei located at the center, with smooth and regular ring structures. Conversely, P-type ring galaxies exhibit off-center nuclei and less regular ring formations. Ring galaxies are exceedingly rare cosmic phenomena, constituting only about 1 in 10,000 galaxies. Astronomers have proposed two primary theories regarding the formation of ring galaxies. Firstly, they may form through the collision of two or more galaxies. Alternatively, a ring-like structure can emerge when a smaller galaxy traverses through the center of a larger galaxy. Well-known examples of ring galaxies believed to have formed from galactic collisions include the Cartwheel Galaxy, Galaxy Pair 2026, 424, and ARP 147. Clearly, the mechanisms underlying galactic interactions are complex, influenced by a multitude of factors. However, the unfolding narrative of the universe presents an even more intriguing scenario. The Milky Way and Andromeda galaxies are purportedly hurtling towards a collision course, destined to merge and give rise to a new supergalactic entity. As a light-hearted jest, people worldwide have humorously dubbed this monumental event Milkometer or Milk Dram. Yet, despite the amusing nicknames, the ramifications of this merger on humanity are profound. Tidal interactions occur when gas, dust, and stars are drawn between galaxies, orchestrating a mesmerizing ballet of celestial matter as star systems interact and collide. The inevitable convergence of galaxies will lead to chaos and upheaval, yet this cosmic dance unfolds gradually. As the galaxies draw nearer, their eventual collision initiates a process known as a merger, wherein stars, gas clouds, and dust clouds from both galaxies intermingle and blend. This union gives rise to new star clusters and formations, weaving fresh patterns across the sky. As the galaxies coalesce, the orbits of stars undergo significant changes, fostering a dynamic and unstable environment within the merged galaxy. During this tumultuous process, some stars may be ejected from the newly formed galaxy, while others may adopt elliptical trajectories to navigate the chaotic aftermath. At the heart of both galaxies lie supermassive black holes, and as they collide, these cosmic titans will amalgamate to form an even larger black hole at the center of the merged galaxy. This merging process can trigger bursts of star formation in regions where gas clouds converge and compress, spawning new stellar nurseries, the cradles of young, massive stars essential for the galaxy's rejuvenation. Upon the union of the galaxies, the night sky transforms into a celestial spectacle, ablaze with millions of luminous stars. The collision and subsequent merger unleash breathtaking displays of star clusters, shock waves, and radiant bursts of energy. These cosmic transformations alter the nocturnal vista, giving rise to new constellations and configurations of stars in the celestial crucible. In essence, when the Milky Way and Andromeda galaxies merge, the heavens will undergo a complete metamorphosis, unveiling an entirely new cosmic tableau. While these cosmic events unfold on a grand scale, their repercussions reverberate far beyond the cosmos. The merging of galaxies unleashes immense cosmic forces and interactions among stars, gas, and dust, with profound implications for Earth. These changes have the potential to impact environments, alter biodiversity, and even threaten existing life forms in affected regions. The merging of galaxies could potentially trigger issues within our solar system, leading to shifts in climate patterns and weather trends on Earth. Such alterations might manifest as changes in temperature, precipitation, and weather phenomena worldwide, thereby influencing the distribution of plants and animals. Furthermore, the escalation of cosmic radiation in the intergalactic space between merging galaxies could impact Earth's environment, including its ozone layer. These transformations could have profound ramifications for weather patterns and the survival of numerous species. The altered atmospheric composition could disrupt vital processes like photosynthesis, thereby affecting the planet's life-sustaining systems. As ecosystems evolve and temperatures fluctuate, habitats may become less hospitable for certain species or undergo complete relocation. This could pose challenges for animal species reliant on specific migration patterns for breeding, foraging, and survival. Destruction of habitats or changes in temperature could disrupt these migratory routes and timings, making it difficult for animals to locate food, water, and suitable breeding grounds. The convergence of the Milky Way and Andromeda Galaxy could significantly impact life on Earth and disrupt the delicate balance of our ecosystems. As climates and habitats undergo transformations, biodiversity and the distribution of life within ecosystems may undergo substantial changes. While the altered conditions might benefit some species, others may struggle to adapt. Increased competition for resources could ensue, and certain species may exploit new opportunities in modified landscapes. Additionally, there may be animal species unable to adapt swiftly enough to the evolving conditions, potentially leading to extinction in their native habitats. Issues concerning habitats and migration patterns can set off a chain reaction within ecosystems, resulting in the disappearance of certain species from specific areas or habitats. While the prospect of such changes may evoke sadness, it's crucial to acknowledge the inevitability of the galaxy's collision. Nonetheless, it's essential to remember that this collision won't occur. The anticipated collision is forecasted to commence approximately 4 billion years from now, with a subsequent integration period lasting another 2 billion years. By that time, humanity will likely have long vanished, and Earth will have undergone significant transformations well before the collision commences. Our Sun is projected to transition into a red giant in roughly 5 billion years, expanding to engulf the inner planets, including Earth. This process is expected to render our solar system uninhabitable long before the convergence of the two galaxies. If any descendants of our species or other life forms exist 4 to 6 billion years from now, they will likely exhibit substantial evolutionary divergence from present-day humans. The impending merger prompts speculation regarding the fate of our solar system within the new supergalaxy. There is a possibility that our solar system may be ejected into intergalactic space during the collision, although the precise outcome and structure of the new galaxy remain uncertain. It is probable that the merging will disrupt the galactic disks of both galaxies and disperse the spiral arms, potentially transforming Andromeda into either an elliptical galaxy or a large disk galaxy. The ultimate outcome will remain elusive until the merger occurs, as the current understanding suggests multiple plausible scenarios. Upon the fusion of the Andromeda Galaxy and the Milky Way, the forces of space and interactions among stars, gas, and dust will reshape the galaxy from its present form. This process of amalgamation will give rise to a unique galaxy, distinguished by its own distinct characteristics. It is conceivable that within this merged galaxy, there may exist star systems with planets orbiting within the habitable zone, the region where conditions are conducive to the presence of liquid water. Liquid water is widely regarded as crucial for the development and sustenance of life as we comprehend it. The stability of the newly formed galaxy structure will play a pivotal role in determining the potential for thriving life. The manner in which stars interact amidst potential gravitational disruptions could alter planetary orbits and environments, consequently influencing the evolution and survival of life on any prospective habitable worlds. Additionally, the merging of galaxies may lead to an increase in cosmic radiation and stellar activity, including rare events such as supernovae and gamma-ray bursts. The timing and impact of these events on the surroundings of other planets remain uncertain. It is probable that any life emerging in the new galaxy will adapt to suit its prevailing conditions. The distinct physical and chemical properties of the new galactic region may give rise to life forms vastly different from those known on Earth. However, it's essential to recognize that individuals from our era would likely struggle to thrive in this unfamiliar environment. The environments and conditions would likely be markedly different from what we are accustomed to, rendering it unlikely for modern humans to endure in such places. Considering these factors, do you believe that humans could undergo sufficient adaptation to flourish in the Milky Way?